Hey everyone, and welcome. I am absolutely thrilled to guide you through this explainer on building the ultimate Ubuntu AI workstation, completely from scratch. Look, if you're a beginner wanting to transform a fresh, plain vanilla Ubuntu installation into a complete, professional-grade AI development powerhouse, you are exactly in the right place. Modern AI development? Yeah, it requires way more than just installing Python. It requires a structured, isolated, and powerful environment. So, grab your coffee, fire up your terminal, and let's build this entire thing together.
All right, let's dive right into this blueprint. We are going to transform your base operating system into a professional-grade AI powerhouse for 2026. This setup is literally the gold standard. We're moving far away from those messy, cluttered environments and building a streamlined machine designed specifically for machine learning, data science, and running local large language models. So, here's our step-by-step agenda for today. We're going to build this layer by layer. We'll start with the core foundation, move into Python and containers, tackle development editors, dive into local AI and libraries, and finally, bring it all together in the ultimate stack.
This perfectly illustrates the path we're taking today, from a totally clean Ubuntu install straight through to launching your own private AI projects. Notice how everything connects here. We don't just magically jump straight to AI, we lay down Ubuntu, then Python, our core tools, version control with Git, containerization with Docker, and then we get to the really fun stuff like JupyterLab and local LLMs. Fun fact, industry surveys consistently show developers can waste up to 40% of their time just untangling bad environment configurations. No way we're letting that happen to you. This roadmap ensures you never run into those awful dependency nightmares.
Okay, number 1, core foundation.
Establishing a secure baseline is absolutely crucial, which is exactly why we kick things off with a simple system update and upgrade. This just refreshes your package repositories and applies critical security patches. You might be wondering, why start here? Well, a stable AI environment requires the absolute latest security and system libraries to function without randomly crashing on you. So always start your builds right here with a quick update and upgrade command. Next up, we install our foundational utilities. We're talking Git, curl, wget, and build essential. These are the absolute basics every single AI developer relies on daily. What are they? Well, Git is your version control foundation for cloning repositories. Curl and wget allow you to pull massive datasets directly from the web straight into your terminal. Build Essential gives you the C compilers you need, because honestly, many major AI libraries are actually written in C++ under the hood for pure speed. And Unzip? Well, you're going to be downloading a ton of zipped data. You will use these tools every single time you set up a new project. Moving right along to Section 2, Python and containers. Just look at the absolute chaos of a polluted system environment compared to the safe, isolated sandbox of an AI virtual environment. If you install every single AI package globally on your Ubuntu machine, eventually different projects are going to require conflicting versions of the exact same library, and boom, your entire system breaks. An AI virtual environment basically creates an isolated sandbox. What happens in the sandbox stays in the sandbox. And the best part, it is incredibly simple to use Python's native venv module to protect your core system from those nasty package conflicts. Once you install the standard Python 3 packages, you just generate your environment and activate it. So why is this so popular in the AI world? Because it's fully native to Python and requires zero extra heavy software to run. You're going to use these isolated sandboxes every single time you start a new Python project. Now, before we look at our next tool, let's quickly define containerization. Basically, it's the absolute secret to keeping complex software isolated and running seamlessly literally anywhere. Think of it like this. If virtual environments protect your Python setup, containers protect your entire operating system. Docker brilliantly illustrates this concept by wrapping our AI tools into neat little containers. Traditional global installations lead to OS pollution and super messy dependencies, whereas the Docker engine runs clean, completely isolated stacks. So what exactly is Docker? It's a platform that lets you run complete AI environments as lightweight virtual machines. Why do we use it? For 100% reproducible projects. If your AI model works in a Docker container on your laptop, it is going to work on a massive cloud server, guaranteed. You'll definitely use this when deploying applications or running complex databases.
All right, let's level up to Section 3, Development Editors. These are the dedicated interfaces where you'll actually be writing your code. On the left, we have VS Code, which remains an incredible industry standard with phenomenal extensions for Python and Jupyter. But on the right, that's Cursor AI, and it is the next-gen IDE you absolutely should be looking at for 2026. What is it? Cursor is actually a fork of VS Code, but it's built entirely around AI from the ground up. You use Cursor when you want inline AI code generation, multi-file code-based indexing, and contextual chat right there in your editor. It basically replaces standard autocomplete with genuine predictive intelligence. It's a real game changer.
We'll also set up JupyterLab for an interactive notebook environment, utilizing systemd to automatically manage it in the background. What is JupyterLab? It's this awesome interactive web-based interface where you can write Python code in dynamic little cells and see the output, like graphs and data tables, immediately below it. Why use it? It is the absolute gold standard for data exploration and machine learning experimentation. You're going to use this whenever you're testing models or visualizing data before writing your final production scripts.
Let's keep the momentum going with Section 4, Local AI and Libraries. This right here is the true computational engine of our entire workstation.
First up, a quick definition. A local LLM, or large language model, is an AI that runs entirely on your own hardware. The crucial takeaway here is that a local LLM means absolutely zero data leaves your machine, keeping your workflow completely private and offline. Instead of paying for expensive API calls to external cloud providers, you are running the brain right on your own desk.
And getting that running is crazy easy. With just a single curl command, Ollama is ready to run models like Llama 3 locally with zero configuration required. Seriously, what is Ollama? It's a seamless local inference engine. You literally just curl the install script, type Ollama run Llama 3, and boom, you are instantly chatting with a cutting-edge AI right in your terminal. Why use it? For 100% private, offline workflows. You use this when you're analyzing sensitive data that simply cannot legally or ethically be sent to a cloud provider.
Then, we add in the AI Python ecosystem. We're talking NumPy, Pandas, Scikit-learn, plus PyTorch and Hugging Face. Combine these, and you have limitless local capabilities. NumPy and Pandas, those are your data manipulation kings. Matplotlib is for visualization. Scikit-learn handles your traditional machine learning. And then you have TensorFlow and PyTorch for deep learning. Now, a huge pro tip for beginners. I do not recommend installing TensorFlow and PyTorch in the same general overview session. They are massive frameworks, and their setup completely depends on whether you have a CPU only, an NVIDIA GPU, or an AMD GPU. So we will definitely cover their specific installations in dedicated future explainers. Finally, Hugging Face is the library you'll use to download millions of open-source models directly into your code.
Finally, we arrive at Section 5, the ultimate stack. This is where we bring all our core tools, Python, editors, and AI libraries together into one cohesive system.
We integrate PostgreSQL for relational data alongside productivity tools like Obsidian and Stacer. You might be wondering, why do AI projects even need a database? Well, real-world applications need to reliably store user data, chat histories, and vector embeddings. On the productivity side, we install the Brave browser for privacy-first web research, Obsidian for managing a Markdown-based local knowledge base, and Stacer. Stacer is great. It optimizes and monitors your Ubuntu system's RAM and CPU usage while those super heavy AI models are running.
Now, while this is entirely optional for CPU users, adding NVIDIA's proprietary drivers and the CUDA toolkit acts as a massive hardware power-up for deep learning frameworks. Look, if you're just starting out, your CPU is totally fine. But when you want to actually train models or generate responses at lightning speed, you are going to need an NVIDIA GPU. This involves installing the proprietary drivers, blacklisting the open source ones, and deploying the CUDA toolkit so tools like PyTorch can actually talk directly to your graphics card.
Bringing it all together, just look at this completed layer cake architecture. It is a beautifully optimized professional-grade AI stack. At the very base, you've got your hardware. Next, Ubuntu and your drivers. Then, your core runtimes like Docker and Python. Above that sits your data and knowledge tools. Then your development layer with Cursor and JupyterLab. And finally, sitting perfectly at the very top is the AI execution layer, with Ollama, your deep learning frameworks, and Hugging Face. And just like that, your Ubuntu AI workstation is completely ready. It is containerized, GPU accelerated, and totally secure for all your upcoming builds. We've gone from a totally blank OS to a machine that is perfectly optimized for local, private AI development. You now have a rock-solid, professional environment. And hey, don't worry if some of these tools feel a bit deep right now. We are going to cover each and every one of these specific tools in dedicated, in-depth explainers in the future.
So, now that you hold the keys to this incredible setup, what groundbreaking AI project are you going to build first? Seriously, I want to know. Are you going to build a local document analyzer? Maybe a smart home assistant? Drop your ideas in the comments below, because I would absolutely love to hear what you're working on. If you found this explainer helpful, please hit that like button, subscribe, and comment which specific AI tool from our stack you want to learn about next. Keep coding, keep building, and I will see you in the next explainer.